Hello, everyone. I'm Justin Kennington, president of the SDVoE Alliance. I'm joined today with Stephane Tremblay, who's the CTO of AptoVision products for Semtech. Steph, welcome.
Thank you, Justin.
I want to start out. Why don't you tell us a little bit about yourself and a little bit about Semtech? You have probably the most interesting SDVoE history of everyone I've been talking to. So why don't you tell us about that?
Yeah, sure. All right. So as you said, I'm currently CTO of Semtech for the business unit AptoVision. AptoVision got acquired by Semtech in 2017. AptoVision was the company that had founded this technology. I co-founded it with Kamran Ahmed in 2011. So super glad to be here now.
Great. Tell us a little bit about Semtech and the AptoVision product line.
Yeah, Semtech AptoVision really focus on the Pro AV segment. We are behind the SDVoE processor, right? Those processors that usually go into SDVoE endpoint. The latest addition to our lineup, which is our flagship product, is AVP2000T, which is an ASIC fully bidirectional for SDVoE application.
I think let's break that down for our broad audience here. You say ASIC, that means a chip built specifically for this application. What's the point of that? Why build an ASIC?
Yeah, building an ASIC in that market is super important. I'm glad you touched on this. Why it's important? For two main reasons. Those two reasons are cost and power, right? Our previous solution was FPGA based. We had paid great attention to minimize power consumption and gate count, but nevertheless, an FPGA consumes more power than an ASIC, and at the end, the solution cost is higher, right? So Semtech had invested lots of money to come up with an ASIC-based solution with equivalent functionality of our FPGA offering, but this one brings power way down and cost as well.
Interesting. So talk a little bit about the path that got us from AptoVision in 2011 and an FPGA idea to an ASIC that's available now.
A bumpy path, I would say, but the focus
why did that take 9 years?
Because we're slow? No. It's because it takes a while to get the technology where it needs to be. So back in 2011, we did really focus on low latency transport over Ethernet. And by low latency was impossible to use 1G solution, right? Because of compression, decompression, the quality was important for us. So we had to make it all run on a 10G backbone. So that was challenge number one. But then again, the next step after that was to provide the video processing capability needed for that market. And by video processing, there's tons of video processing capability now, color space conversion, scaling, display wall capability, multi-viewer, compositing. So there was a lot to be developed, not only to make it work, but make it stable and interoperable across SDVoE vendors.
And maybe that's the important thing to highlight about the time taken is because this was brought to market first on an FPGA, which is a more flexible solution, right? Despite its drawbacks, it's easy to modify and easy to change. I think the mileage that the product gets on FPGA is very valuable when you move it into an ASIC that's less flexible, because now you have a solid and stable working technology that the broader market can employ.
Yes, definitely, Justin. And as you pointed out, being stable is tough. The reason it's tough is you cannot say, okay, I'm going to keep my technology in my own lab, validate my own way, and expect to be interoperable and stable in the field, right? So you need to have field time. So for us, it was the perfect storm as we started the technology being FPGA based, version 1, 2, 3, 4, and then getting more and more stability. And once we hit that stability point where, you know what, the defect per 1,000 are slim to none, and we can go ahead and make an ASIC out of this technology, was perfect. So that's what we did with the Semtech acquisition. Semtech is an ASIC company, right? And this is where we had decided to cast in stone that technology, which is now the SDVoE technology we all know about.
How did the idea start? What was the original inspiration that led to what is now SDVoE technology?
Um, Good question. I cannot say exactly how and when it all started, but 10 years ago, it was obvious to me that matrix switch would be replaced by Ethernet switch. And it was not only because of cost, flexibility, scalability, but also the fact that Ethernet always wins, right? I cannot just think of any technology that had resisted Ethernet for long, right? So, but the problem back then was about the available cost versus bandwidth over Ethernet switches. 1 gig was just not enough to replace matrix switch experience in terms of quality, right? If you need to compress the signal, and latency. No one expects high latency out of a matrix switch. So looking at the price drop of 10 gig switch, I co-founded AptoVision with Cameron Ahmed, as I said, in 2011. Then really started to design IP literally in my basement to cut the latency over 10 gig network. And the goal at that time was to preserve the full source gen locking and video processing capability. And we started really focusing on transport, perfect end-to-end transport, low latency. And then once we had reached that milestone, we had bring up some video processing capability to the platform.
Let's talk about that video processing capability, right? So SDVoE, the core technology goes well beyond transporting video, right? The matrix switch is about moving video from A to B. And at its core, maybe you'd say SDVoE is about moving video from A to B, but the chipsets can do a lot more with that video. So what's the reasoning for that? What are the applications for that? And what are those processing things?
It's all about leveraging the power of an Ethernet switch, right? As you know, an Ethernet switch is not just a circuit switch that connects one input to one output. It's way more sophisticated. And leveraging that power, you can do applications that previously would have costed lots of hardware and power to do, but now it becomes for free. I'll give you an example. The display wall application is a perfect example. Previously, display wall, you would have to have an FPGA that takes the complete signal, break it down, etc. Whereas with an Ethernet switch, it's packet-based. So you subscribe to the chunk of packet you need, and that's it, that's all. Multi-viewer is the same example, right? A multi-viewer is a receiver that now subscribes to many multicast channels at the same time and just take the information it needs. So for us, adding video processing capability was a natural evolution of that platform.
What were some of the challenges of developing the platform? What was the really hard technical stuff?
I would say the biggest challenge was to provide extremely low latency over multiple Ethernet switch up. So in other words, the clock recovery part was the hardest part. Others had developed some clock recovery mechanisms to require some time base, but no other has the technology out there that the SDVoE clock recovery has. I'll give you an example. It's easier to understand with an example. Take the low latency gen-lock scaling mode of SDVoE, right? This mode of operation can recover the original pixel clock, produce a brand new pixel clock, completely different frequency due to different scaling ratio, and reclock the scale output in microsecond range, right? The closest other than SDVoE clock recovery technique would be those clock recovery that are VSync based, but unfortunately those technique would yield a much higher tracking skew, and the microseconds tracking skew is impossible with those techniques. So SDVoE clock recovery is really a notch above all the other techniques out there.
worth reminding our viewers, a microsecond is 1/1000th of a millisecond.
Yes.
So we're talking about extremely fine precision here. And I think you're highlighting the clock recovery. What's important functionally about that, I think, is that this is what makes SDVoE agnostic to switch choice, right? You don't have a technology like AVB requires you to have an AVB compatible switch, right? That's essentially so that they don't have to do clock recovery on their own. But because SDVoE has this baked in, where we're compatible with any make, any model of switch that can support the 10 gig bandwidth.
Yes, you're right, Justin. And to be more specific about what you are describing is other techniques would involve PTP, precision time protocol. And unfortunately, I'm not saying that PTP is not a good technique or not good tools, but it requires support from the Ethernet switch. And lots of Ethernet switches don't have support for PTP. So this is why we had to go the extra length of designing something that could survive a non-PTP switch, but at the name of greater interoperability with different Ethernet switch vendors.
I've always said that an AV designer walking into an IT director's office and telling him he's going to have to replace his Cisco's is more likely to get the AV designer replaced than the Cisco's.
That's probably right.
What aspects of SDVoE do you think have been maybe undervalued or overlooked?
Undervalued is really interoperability, right? Everyone knows that SDVoE is interoperable, but let me take 1 minute to say that SDVoE is a full stack solution. That's what's making it interoperable, right? Compared to HDBaseT or SMT 2110, and you'll see the real power of SDVoE interop. You can literally connect different SDVoE products together from different vendors, and they will just work. Any switch, any endpoint. Try it with HDBaseT or SMT 2110, and you might see basic functionality, but forget about the full feature set, right? Interoperability is a big generic term, but really SDVoE is the benchmark for it.
What has been the benefit of the SDVoE Alliance for you and for Semtech?
The Alliance is the place where, because we have different vendors part of the Alliance, this is the place where we can regroup and educate people, right? SDVoE is a technology, so the manufacturers and the vendors know about this technology, but what about the end user? What about the installer? What about the system designer? So really the SDVoE Alliance is the place where we can educate and promote the technology. This has a very high value for all of us.
Yeah. The SDVoE Academy is there to sort of to close that knowledge gap that exists between AV pros and IT pros, and help bring those worlds together. Mm. So you sort of sit in an interesting position, right? As CTO of a pure technology group in Pro AV. From where you sit there, what do you see as our future as an industry? Where do you think Pro AV is headed?
I'm glad you asked. I will say really bluntly, Ethernet always win. So it will just go over Ethernet. All Pro AV will go over Ethernet. It's the end of the matrix switch, period. But the more challenging question would be, okay, which technology will win over IP, right? And I think there's room for more than one here. That truly depends on the application. I think the last mile interconnect will always be low latency and no compression. There's certainly no doubt SDVoE will win that battle. But there are other applications, for example, very long haul transport, where compression is needed. So who's going to win the compression battle? This one is a tough call because H.265 is certainly ahead in the 4K compression round, but it has high latency which are often not desirable in Pro AV. So this one is a tough call. I won't commit on this one, Justin.
That's okay. As long as SDVoE is winning,
Yeah.
we'll look forward to finding out who also wins.
Mm.
Well, we've covered all the ground that I wanted to. If there's anything else you'd like to talk about, let me know.
Perfect, Justin. We'll stay in touch.
Great. Well, then we'll wrap this up. Thank you for joining, Steph.
Okay, no problem. See you.